Good morning. This is Ms. Billerbeck, and we're going to talk about rewriting radical expressions. So we have the product property of square root states that the square root of AB equals the square root of A times the square root of B when both A and B are greater than or equal to 0. So let's take a look at square roots. So if we look at the square of 1, so a square of 1 here has one side length all around. So the side would be the square root of 1, because if we remember, area equals length times width. So if it's a square, the sides are the same. So 1 times 1 equals 1 squared. So the side length would be 1 unit. If we have a square of 4 units squared, the area of the square, so it has 4 unit squares inside of it, then each side is 2 units. So the square root of 4 is 2 units. If we look at the square of 9 units squared, so in here we have 9 units, and we know length times width is 3 units times 3 units. So the side of length is a square root of 9, which is 3 units. If we look at 16 units squared, so we have 16 units in here. So one side is 4 units and one side is 4 units for our length times width. So the side length equals the square root of 16, which is 4 units. If we look at 25 units squared, we have 25 units squared here. So we have a length of 5 units and a width of 5 units. So the square root of 25 would be 5 units. So let's take a look visually at what this is when it's something like this. So if we have 64 units squared, and we want to find the square root of 64, well, this would be the square root of 64. So we'd have the square root of 64 units here and the square root of 64 units here. Now, if we want to compare it to 2 of the square roots of 16, well, we know that the 16 has a 4 by 4. So if I have 16 squared, and a second 16 squared here, both of these widths are the square root of 16 units. And then up here, I have the square root of 16 units plus the square root of 16 units. So in this case, we see that the square root of 64 equals the square root of 16 plus the square root of 16 when we put it in an actual drawing like this. So the square root of 64 equals 2 of the square roots of 16. So let's compare each radical expression. So I have the square root of 36. So I know that if I have the square root of 36, I have 36 here, and this is the square root of 36. I also know that this is the square root of 36, and I also know that 6 times 6 equals 36. So I can say that the square root of 36 would equal 6 because that's the same length as that on squares. Now, if I look at this, I see, well, this particular one, I have the square root of 6, which is much smaller, but I have 3 of them. So that would be 6 squares of 6, or 3 squares of 6. So I'd have the square root of 6, the square root of 6, and the square root of 6. Okay, so that's slightly different than this. Now, if I know that I have 3, and if I put 3 square root of 6, and I know that the square root of 9 equals the square root of equals 3. So the square root of 9 equals 3, and the square root of 6 equals the square root of 6. Then using the fact that 9 times 6 equals the square root of 9 times the square root of 6, now I can say, well, that's the square root of 54. So the square root of 54 must be bigger than the square root of 36, because that's a larger number there. So that's another way to compare this. All right, so let's compare these. So I have 6 square root 2, and I have 72. So if I take 72, and you might remember this from Singapore Math 7, is you take 72 and you prime factorize. So you take that out, you get 36. And right here, before we even prime factorize, we know that that's 6 times 6. So, and then of course we have, if we continue to prime factorize, we have this. Okay, so we see that we can take pairs out of the house, the square root house. So right here, we already have a pair, so we don't need to deal with all the primes. So we can take the 6 out of the house, and then we'd have the square root. So let's do that in a little more detail. So the square root of 72 equals, and we can even do this with the primes. So I have 1, 2, 3 2's, 1, 2, 3, and I have 2 3's. Now it's a square root house, so you can only leave the house in pairs. So I have a pair of 2's and I have a pair of 3's. So they can leave the house as the square root, well, as a united front of 2 and a united front of 3, but this 2 is alone, so it stays home. So we have a square root of 2. Now 2 times 3 is just 6 square root of 2. And that's what we're comparing it to. So 6 square root of 2 equals 6 square root of 2, which is the square root of 72. Just simplified. All right, so let's rewrite each of these expressions to remove perfect square factors like we did with 72. So if we look at 44 and we take the prime factors out, we have 2, we have 22, we have 2, and we have 11. So we have a pair of 2's here that can leave the square root house. The 11 would be alone, so it would stay home. So this would be the square root of 2 times 2 times 11. So the 2's leave, so we have 2 square root 11. Now, if we do this one, we have 27. We take a 3 out, we have a 9. We take a 3 out, we have a 3. So we have 3, and then we have a square root of 3 times 3 times 3. So I have a pair of 3s that can leave, and there's a 3 out here already, so they meet up outside the house. This one's alone, so it stays home. So that 3 stays there. Now 3 times 3 is 9, square root 3. All right, so let's take a look at this one. So this one, we know that 25, the prime factors are 5 times 5 times x times x times x when we have x cubed. So this can leave the house and this can leave the house. So this equals 5x and the square root of x here, because this x is alone, so it stays home. Now, when we get into larger numbers like this, we might want to have an even amount of a pair of x's that have the same, just to make it simpler. So we're not expanding 17 x's. So we have 5 times, and we know that 4 factorizes as 2 times 2. And then we can say x, and let's say that's x to the 8th times x to the 8th times x. So x to the 1 right here. So 8 plus 8 is 16 plus 1 is 17. So I have a pair of 2's that can leave the house and a pair of x to the 8th that can leave the house. So this ends up being 5 times 2 and then times x to the 8th with that one remaining x and in the square root house. So then I end up with my final answer of 10, x to the 8th square root x. So you can see you can go to the nearest even number that's less than 17, divide by 2, and you can find what you can take out of the house when it's an algebraic term. So let's take a look at this one. So we have 1/2 out here, and we're going to multiply. Now we can multiply, rearrange this using the commutative property of multiplication, and do 1/2 times 4. They're acting like coefficients to the square root. So let's just put them out of the square root house. Now we also know that this can be combined with that. So we can put this all into one square root house of 21x cubed times 7x squared. So now we can pull the factors out, the prime factors out, to see how we are going to go ahead and simplify the square root. So 1/2 of 4 is 2, so we can handle that right now. 21's prime factors are 3 and 7, so 3 times 7. And this is not an even number, so let's take out the even number here, x squared times x, and then we have a 7 here times x squared. Okay, so this is our x to the 3rd right here. We see that we have a pair of x's and a pair of 7's. So we can take this 7 and this 7 out as a united front of 7. So we have 2 times 7. We can take this x squared and this x squared out. And what remains in the house that it's alone is 3x. So we end up with the square root of 3x. So our final answer then will be 2 times 7 is 14. X squared on the outside of the square root house. And then inside the square root house, we have 3x. So this does not have any coefficients to combine, so this 2 will just be out there. So let's go ahead and put it all into the square root house together. So we have 12x to the 9 times 18x to the 5th. So let's prime factorize inside the square root house and see how we can simplify this. So 12, if you're not familiar with 12's prime factorizing, it is this. So we have 2 times 2 times 3. Then I want this to be an even number, but we also have x to the 9 times x to the 5th. So that's going to be x to the 9 plus 5. And then we have times, and 18 prime factorizes as 2 times 3 times 3. All right, so we see we have a few pairs we can take out. So let's do that before we consolidate too much. So I can take one of the 2's out here and a 3 out here. And I have a 3 left and a 2 left, and they're alone. So 2 times 3 is going to remain in the square root house, and that is 6. And then that's x to the 14. Okay, this I can divide by 2 and take that one out, because we can see in this next step, 2 times 2 times 3 is 12. And then we have 6, and this is the same thing as x to the 7 times x to the 7, because 7 plus 7 is 14. And now I have a pair. So my final answer for this is going to be 12x to the 7 times the square root of 6. All right. So let's do a word problem about ice cream cones. Okay, so we have this cone and it has a slant height. So the slant height is this right here on the cone. Okay, and it's 5 times the radius. So let's note that S equals 5R. Okay, what is the simplified expression for the height in terms of the radius? So here's the height of the cone. It starts from the point of the cone to the very middle. So if we see this cone from this perspective, the height is going right to this very middle section, and this is our radius right here. All right, so we can substitute this in here because we need to get the height in terms of only the radius. So we have 5r squared equals r squared plus h squared. So 5r squared is 5 squared, r squared, and that's equals r squared plus h squared. So let's subtract r squared from both. Well, let's not do that just yet. So 5 squared is 25, r squared equals r squared plus h squared. So now we can subtract the r squared, and that's 1r. So we get 24r squared equals h squared. All right, so what we're going to do is we're going to take the square root of both sides. So the square root of everything has to be positive, so we can't have any negatives when we're taking the square root. So we're going to say that h is going to be the square root of h squared because there can't be a negative height. And we're going to say, so we're going to take the square root of this and the square root of that. So the square root of 24r squared equals the square root of h squared. So now we have h on this side. And in here, we can prime factorize the 24. So let's do that really quickly. So 24, we take a 2 out, we get 12. We take a 2 out, we get 6. Take a 2 out, we get 3. So that's 2 times 2 times 2 times 3. And then we have r, need a little more room, times r equals h. So I have a pair of 2's I can take out and a pair of r's I can take out. So I get 2r, and then inside here, I have the square root of 2 times 3, which is 6, equals h. So in terms of r, so h then equals 2r square root of 6. And that's it. All right, you have a wonderful day. Bye-bye.